I think so. No, not salt. As we discussed about this pH and this pH and what is a how we can going to differentiate strong acid, weak acid, strong base, and weak base based on the pH values. Now we are going to discuss about salt. Salt family of salts. The more about salt topic. We are discussing about family of salt. We are then after we are going to discuss about pH of salt. After chemical, this NaCl is used as a chemical for different salts preparations. Okay, that like example like NaOH. How we are going to prepare by using NaCl and NaOH, and then after bleaching powder, baking soda, washing soda, and all. Okay, now see, try to understand here what I'm saying. First thing they given about family of salt. See, salt means we know very well. Salt means it is an obtained from the usually sea, so from the sea by the process called evaporation. It is one part. In chemistry, what happens when the neutralization reaction is going to take place? You know very well. Neutralization reaction is taking place between the acid plus base. When aqueous solutions of acids and bases are going to react, it is going to form a salt and water. In that reactions, we are going to get a salt, right? So now we are going to classify salts based on the cation and anion present in them. Suppose if you taken the sodium chloride, sodium carbonate, sodium sulfate, in these all three salts, sodium is a common cation. So these kind of salts are also classified as a salts of sodium. Similarly, even if it is anion is also common. Suppose if you taken potassium chloride, sodium chloride, magnesium chloride, calcium chloride, here chloride is common, right? That's why these salts also called as what, sir? We can call them as a chloride salt. So based on the common cation and common anion, we are going to categorize salts into two ways based on the what kind of common anion is a common cations are. Let me discuss how we can classify them actually. Now see here they given different salts, right? They given different salts here. Now let me discuss about first beginning of the concept actually. More about salt, family of salt. Here they given different salts, potassium sulfate. So you can take this salts actually. So see here you can see they given salt chemical. Write the chemical formula of potassium sulfate, sodium sulfate, calcium sulfate, magnesium sulfate, copper sulfate, and sodium chloride, sodium nitrate, sodium carbonate, and ammonium chloride. See, try to understand. Here, what is the common thing here? Potassium sulfate is common, sodium sulfate is common, calcium sulfate is common, magnesium sulfate, copper sulfate. So in these salts, sulfate ion is common. Similarly, sodium chloride, sodium nitrate, sodium carbonate. Here, sodium is common here. Similarly, ammonium chloride is there. Let me discuss here. Then we'll come to know how to classify these salts and all. Okay. Okay. Now, now see, even sodium, calcium, magnesium, copper. Sodium chloride they given here. So let me write sodium sodium sulfate Na2SO4. Okay, then after sodium sulfate is made up of two sodium ions are there, two Na plus ions and sulfate ions will be there. Sulfate charge is -2. Similarly, they given about calcium sulfate. I think they given about calcium sulfate. Formula will be CaSO4. Take CaSO4. It has a Ca plus 2 ions, and similarly we have a SO4 minus 2 ions, sulfate ion. Similarly, they given about I think even copper sulfate also. Let me write copper sulfate formula will be CuSO4. So Cu forms Cu plus 2 ions and SO4 minus 2 ions. Okay. After they even go to check once sodium sulfate, calcium sulfate, magnesium, copper, sodium. Magnesium sulfate also they given here. Magnesium sulfate MgSO4. The formula of magnesium sulfate. Right? Magnesium sulfate will form magnesium. plus 2 ions and sulfate ions. This is kind of one category of what we can say. We can say as this will be an one category of salts. Now see remaining are there. They given about now sodium chloride, sodium nitrate, sodium carbonate, sodium chloride, nitrate, carbonate, chloride, sodium chloride, NaCl, sodium nitrate, NaNO3, and sodium carbonate, Na2CO3. Then they given so then after what they given sir. And after they given about something called copper sulfate, sodium chloride, sodium nitrate, sodium carbonates, ammonium chloride. Right, ammonium chloride also. Ammonium chloride is a NH4Cl is a formula. Now see, this contains Na plus ions and Cl minus ion. Similarly, again Na plus ion and NO3 minus ion, nitrate ion. Similarly, it have a 2 Na plus ion and CO3 minus 2 ions. Similarly, it contain ammonium ion, NH4 plus ion and Cl minus ion. Now, what is the common thing here? Should remember here. Okay, here what is a common thing, sir? You see, if I can understand here, sulfate is common. Sulfate, sulfate, sulfate. What about here, sir? Na plus, Na plus, Na plus, and that is not Na plus, it is ammonium, right? Now see, what is the common answer in this case? What is the common here? In this case, anion is common. Anion is common, or we can say let it be anion only. Let we call anion only. So, what is the common answer here? We can say here cation is common. Which cation, sir? Which cation? It is Na plus cation, right? Similarly, which anion here? SO4 minus 2 ion. This is called which is, sir? It is called sulfate ion. This is a sulfate ion. Similarly, here what it is, sir? It is called sodium ion. Then we can call this as a salts of sodium. Salts of sodium. Similarly, I can call as this is what, sir? It is called salts of sulfate. So in this way, we are going to classify salts into based on the what kind of common cation or what kind of common anion. So one more classification also we can do here. So just you can do the observation here. There are some more common ions. What is the common ion here, sir? Chloride. Here also chloride. So these two also we can call as a salts of what, sir? Salts of chloride, salts of chloride, salts of sodium, salts of sulfate. Why these all called this way? Because these all group contain same cation or same anion. Based on this, and this question we try to understand in 2024. This question they asked already. Okay, try to understand as a 4 marks question in the case-based study. Case study questions. Okay, what about salt they asked actually. So then after you see, then come to the next topic of this concept, this chapter. They given about something else. What something else? They given about identify the acids and bases salt is formed. So family salts. Now see, now they are asking people to identify the acids and bases from which these salts are formed. Okay, negative radicals are used to belongs to what some positive and negative radicals are said to be belongs to family. For example, NaCl. NaCl is made up of what, sir? We discussed already. Na plus ions and Cl minus ions. Similarly, they given about Na to SO4. We discussed already. Na plus ions are there and SO4 minus 2 ions are there. Similarly, they given here to sodium salt NaCl, KCl. So NaCl have a which common ions are Cl minus ion plus Na plus. And similarly, if I taken KCl, I can write as a K plus and Cl minus. Here also what is the common ions are? These are to the common ion. That's why we can call these two as a what's that? This is called as salts of which ions are salts of chloride ion. Okay, so we can see chloride salts. The given is chloride salt here. Now pH of salt. They're asking you people to find out what here. They said to find out what's that? They said to find out what are the acids, what are the bases to form these salts. What is the story behind this? Because whatever salt we are getting, we need to find out. They asked the people to find out the pH. Next concept is finding out the pH of salts. Okay, pH of salts is depending upon the what kind of acids and what kind of bases are used. See, next concept is what, sir? Next concept is next concept. See, right now, so we discussed right now about the classification of salt based on the common cation, common anion. So in the question, they may be asked what are the common ions or why we are going to classify into particular like salts of chlorides, salts of sodium, salts of sulfate, salts of carbonate. So you should know that what are the common ions. That common ion will be used as a particular salt family: chloride salt, sodium salt, calcium salt, sulfate salt, and after magnesium salt, carbonate salts. Okay. So now we will discuss about pH of salts. You try to understand here. Just now we said that salt is going to form because of which reaction? Because of neutralization reaction, right? In the neutralization reaction, definitely there will be one acid, and it is going to react with the base. It's forms salt and water. Now, why? What is the relation between this neutralization reaction and the pH? Sir? Because in that neutralization, suppose we have a strong acid, we have a strong base, then the resultant salt will be neutral salt. Or else if we have a weak base and weak base and weak acid also will produce a neutral salt. Suppose if we are using strong acid and weak base, result will be what's a acidic salt. Okay, you know very well, if it is acidic salt, then what will be the pH? Sir? pH will be less than 7. Similarly, if suppose we are using a strong base and weak acid, strong base and weak acid, then salt would be salt would be what's a strong basic salt will be there, and basic salt means pH will be more than 7 will be there. So this is the way of identification of pH of salt based on the what kind of acid and what kind of bases we are going to use. Okay, it will discuss. We are going to discuss about discuss about pH of salt. pH of salt is depending upon what's a salt is result of what? Actually salt is result of acid plus base, gives rise to what? Sir, gives rise to salt and water. Salt and water, and you know very well this is heat energy also going to produce. That's why even this neutralization reaction will be neutralization. Neutralization reaction is also called what? It is also called a exothermic reaction. Why it is exothermic? Because in this reaction heat is going to produced. Okay. Now what I'm saying, now we are going to find out pH of this salt. pH of this salt, we are depending upon what? It is depending upon the what acid and what base we are going to use. To discuss then what they given here. As you can see that they given here they given sample of sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate, copper sulfate, sodium mustate. Now we suppose discuss about sodium chloride. Before that, you try to understand. Suppose we have a salt. We have a salt. With salt we have salt. Think like we have a. We will get a neutral salt. So when we are getting when you are going to get neutral salt, sir, so suppose if we have a strong acid, suppose the reaction is going to take place between the strong acid plus a strong base, plus a strong base, and what will be, sir, here? It will be an neutral salt. It will be a neutral. It will be a neutral salt. Okay, plus water will be there. Okay. Suppose similarly, if we have a weak base, if we have a weak acid plus weak base. What is the result, sir? Here also we can expect neutral salt because both are weak here. Neutral salt will get. So two cases we are getting neutral salt. One is a strong acid. One is strong acid. One is strong acid with a strong base. Weak acid with a weak base. In these two cases, we are getting what kind of salts are neutral salt. Just to remember. Okay. Now, when you are getting acidic salts, when you are getting acidic salt, now see, acidic salt will be Again, what happens, sir? Again, we should see, if we are using strong acid, we are making reaction with the weak base. Weak base. What is result here? Result will be acidic salt. Acidic salt. Okay, plus water. Okay, what is the conditions are strong acid. Strong acid means here. So here we have sodium chloride, potassium nitrate, we have ammonium chloride, zinc sulfate. See, here they given potassium nitrate, ammonium chloride they given, zinc sulfate they given, copper sulfate they given. You see, aluminum sulfate, zinc sulfate, and aluminum chloride. We discuss about the aluminum chloride. See, here is said we have something called HCl, which is a strong acid, and we have a aluminum hydroxide AlOH taken twice. Now see, this is example for weak base. This is example for strong acid. Result will be AlCl3 plus H2O. This is which salts are? This is acidic salt. Result will be what, sir? This is acidic salt. Acidic, then what is the pH, sir? pH will be less than 7. Acidic means pH will be less than 7. Next, one more salt. Example for one more salt. So we can say sodium carbonate. So sorry, zinc sulfate and copper sulfate. Zinc sulfate. You see, again we have a one more base called ZnOH taken twice, and we are using strong acid, sulfuric acid. H2SO4 is a strong acid. Result will be what? The result will be ZnSO4. ZnSO4, and it will be water will get. Again you see, again result will be acidic salt. pH will be what's less than 7 as it is. Similarly, we have a copper sulfate. Here, copper sulfate is formed due to the reaction between copper hydroxide and sulfuric acid H2SO4. Again, what will the result here? We'll get a copper sulfate plus H2O. Okay, these are the, again pH will be what's less than. These are the what's these are the acidic salts. These are the acidic salt. Remember, these are the acidic salt. Acidic salt. What is the conditions are? Condition is strong acid should be there and weak base should be there. Then you will get acidic salt. Okay. Now come to the basic salts. Now come to the basic salt. When you will get the basic salts. So let me write here. Now basic salt. Basic salt will be obtained how, sir? This is due to the weak acid. Condition weak acid should be react with a strong base. Strong base. Then you'll get a basic salt. Basic salt plus water. Now see, what is a strong base? For example, I'll take a strong NaOH is a strong base. If NaOH react with, let me think like it reacting with acid called H2CO3, carbonic acid. Result will be Na2CO3. Na2CO3 plus H2O. Suppose if we have a NaOH, sodium hydroxide, which is strong base, we have acid called CH3COOH, acidic acid. Result will be CH3COONA, sodium acetate plus H2O. These all are example for here. Sodium. So one more example that we discuss what they given here. We discuss sodium carbonate, sodium acetate, sodium hydrogen carbonate. Again they given sodium hydrogen carbonate. Again we have a NaOH. Okay. Again we have a same carbonic acid H2CO3. We know very well. Here you see NaHCO3 is going to form. Okay. So now set right understand here. Now here we are sending more amount of CO2 in this case. More amount of acid we are taking. More amount of acid we are taking. Less amount of NaOH we are taking. In that cases we get these salts. Okay. Anyway, this is an what? So this is these all are the basic salts. Now see, next we'll discuss about when we get a neutral salt. So we have a so here we have a strong acid. Okay. So here we have a Na strong base it is, and HCl strong acid, reaction will take place, NaCl plus H2O. So this is what salt, this is a neutral salt. Neutral salt means what, sir? pH will be approximately 7. Like we forgot to discuss about this pH. See here these all are what kind of salts are these? All are the basic salt. Basic salt means pH will be more than 7. So OH ions will be what, sir? More as compared to what, sir? As compared to H plus ion. H plus ions will be less. Okay. So remember here, H plus ions and pH will be both are inversely proportional. Now see, these are the neutral salts. Similarly, if I take a weak base, suppose let me think like we have a CH3COOH weak acid, plus here we have a ammonium hydroxide NH4OH. Okay, then what will get here? So we will get a I think CH3 COONH4. Okay, ammonium acetate, ammonium acetate plus H2O. This, remember, its name is called ammonium acetate. So this is about different type of salts. This is strong base. This is strong acid. This is weak acid. This is weak base. In this both the cases, salt will be neutral salt. Salt will be neutral. This is neutral. This is neutral. So both we are taking strong base, strong acid, or weak acid, weak base. Both the cases we are going to get a neutral salts. Okay, now come to the next topic. So next topic, pH also we discuss the pH should be now chemicals from the common salt. Now just think like think about this. Mm, they given about here and just they given about rock salt, beds of rock salt, and they are given here rock salt is mine like coal. Okay, let it be, no issues for us. So now, deposit of salts are found in the several parts of the world, and these large crystals are often brown. This is important. Why this is important, sir? Brown color will be because of impurities. Okay, rock salt at the beginning it will be a brown color because of what, sir? Impurities. Okay, this you remember. Now and we'll discuss about next concept. The next concept is common salt. Common salt used as a raw material. Let me read out what they given here. Sorry. So here they given here common salt, raw material for the chemicals. Common salt is obtained as important raw material for the various material of daily uses such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. Okay, so sodium hydroxide. So when sodium hydroxide, when electricity is passed to the aqueous solution of sodium chloride, called a brine, they will call decompose. It decomposes from sodium hydroxide, and the process is called a chloralkali process because products are from this chlorine and alkali and for the sodium hydroxide. Okay, so chlorine gas. So what they given here? Let's see here. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products are produced in this process are useful. Figure 2.8 blah 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 they given. So let me discuss about this diagram actually. So let me take this diagram. So okay, this diagram, right? Hmm. Now we can take control screenshot. Okay, now we'll take it. See, let me discuss about how this process is going to take place. So, just we are discussing about preparation of sodium hydroxide. Preparation of what is the topic name, sir? I don't understand. Topic name is preparation. Just a second. Now see here. What I want to say here. Just let me bring this one. Yes, what we are discussing. Discussing about you see here. Here, one preparation of sodium hydroxide. How it is going to prepare sodium hydroxide? Try to understand here. Okay, we discuss this one. List. So see the diagram. We discuss what is there in diagram and all. You try to understand it. Now, main thing is you should remember that main thing is we are taking NaCl. We are taking aqueous NaCl, right? Plus we are adding water. Okay. What's the aqueous NaCl again? Water. Aqueous NaCl is saturated NaCl. So I'll say what is the meaning of saturation and all. It forms NaOH, sodium hydroxide, and Cl2 and H2. This reaction is going to take place. Okay, to discuss. Okay, here what they will do here. From here they will send 26% of NaOH. So sorry, NaCl. Okay, this NaCl will be split into Na plus ions and Cl minus ions. And membrane here. Okay, this membrane is such that it will allow this Na plus ion from here to here. Allow this Na plus ion will start to move from here to here. They will come here. Why? Because you try to understand. There is a positive charge upon the sodium, so it should be attracted by the cathode. So cathode, this is negative, sir. This is negative electrode. This is what's a positive electrode. Cation is there. It is going to attract by the negative electrode. That's why sodium will come from the left compartment to the right compartment through this membrane. This membrane specialty is it will allow only the small ions, cations, not anions. Right? Understand here. First thing you should try to remember. So let me write here. So when we are taking NaCl plus H2O, there are different ions are going to produce. One is H plus ions from the water, OH from the water, and similarly Na plus from the NaCl, Cl minus from the NaCl ions are going to form. Now see, here try to understand this sodium have a positive charge attract by the negative ion cathode. That's why sodium want to come this side. Okay, also Na plus and what more one more ion, sir? One more ion is what, sir? H plus ion. Similarly, remember. Now see, now from sodium, this sodium came this side, right? H plus ions also will be there. So you try to understand. Sorry. Here NaCl we introduced into the chamber, right? NaCl split into Na plus ions and Cl minus. As this is mixture of Na plus NaCl and H2O. NaCl from H2O. Let me write. Better we'll discuss here. Let's tell right here. Now see. Now what I am to say. This process we are taking NaCl, aqueous NaCl, around 26% saturation. Means what do you mean by saturated? Saturated means, remember, okay, maximum amount of salt. Maximum amount of salt, okay, at particular temperature is dissolved in solvent, or we can say temperature at which no more salt can be dissolved is called saturated solution. Okay, no more salt can dissolve, but temperature at which no more means what we are taking. Just we are taking the beaker. Think like we are taking the beaker and we are going to add. So what I'm saying, just I'm saying that we are going to add. We are going to take a beaker and we are going to add the keep on the salt. Think like NaCl we are adding. Okay. See, suppose we had a 26 gram, 26 for every 26 gram will be in 100 ml of water. This is called 26% of NaCl. Then after remaining salt will be remains here only. If we added here, salt will be left where left over. Okay. So we are keep on supposing like spoon by spoon I am adding salt here. Okay, first spoon, second spoon, third spoon, so on spoons, number of spoons of salt we added at one temperature. At one temperature, next spoon. Suppose think like till we added 10 spoon of when for the 11th spoon of salt, the salt is not going to dissolve, not dissolving. At that condition, that solution is called saturated. They given what is temperature at which no more salt is going to dissolve. They given temperature at no more salt is going to dissolve. Okay, no more salt is going to dissolve. It's called what's called saturated. Saturated means you are keep on adding the salt at particular time. Salt is not going to dissolve. At that condition, that solution is called what's up. This solution is called what's up saturated. Saturated means remember that mixture maximum amount of salt we added. Maximum salt is dissolved already. Next, we are not going to add any salt, and even if you are adding also, that is not going to dissolve. That is called saturated. Now, see, I can understand. So that salt, as kind of saturated salt, they taken in the a chamber. Which chambers are thoroughly process chamber. Okay, electrolysis chamber we can say. Try to understand here. Now, NaCl, aqueous NaCl, we are sending. Okay, plus we are adding from right side, we are passing H2O. What happens here? So you try to understand here. Simple thing is Na plus ions, Cl minus ion. Similarly, from the water, H plus ion and OH minus ions are going to form. Okay, now see, sodium ions carrying a positive charge, H plus ion carrying a positive charge. Where these two will attract, they will move towards the cathode. Towards cathode means what, sir? It is a negative electrode. Similarly, now we have a chloride ions and OH ions. Where they want to go? Where they want to go? They want to go near. What's the near anode? But for the OH, it can't. Why it can't? Let me see. Now come to the this diagram. Okay. Now see what I'm saying here. Now we have a this chamber, right? This chamber. Let me erase these all things. Okay. Okay. Now which ions we discussed just now? We discussed about which ions? We discussed about some ions. We discussed which ions we discussed. Some Na plus ions, and you see from here what we are sending NaCl means what we are saying NaCl aqueous, which is called brine. Brine means aqueous NaCl. It means Na plus ions are introduced here, Cl minus ions also introduced here. Similarly, from here we are sending one more. They didn't give actually. There is an water they will send here. From water, H plus ions will produce and OH minus ions are produced here. From this side, we are sending a brine which is called aqueous saturated aqueous NaCl. Saturated aqueous NaCl. Okay, right from left side of the chamber, we are sending to the towards a we have a electrolytic cell, or we can say electrolysis cell. In that cell we are sending from the left side brine solution means aqueous NaCl, which contain Na plus ions and Cl minus. Saturated, remember saturated means maximum amount of salt is dissolved in that solution. That solution contain maximum amount of salt. After that you can't dissolve NaCl. Whatever NaCl we added, we are keep on adding the NaCl at a certain time. After certain time, what happens? Then where no more salt is going to dissolve, that condition, that solution is called saturated solution. Here 26% saturated NaCl is introduced into the electrolytic chamber. Now what happens now? Na plus ions are going to form here. Na plus ions and Cl minus ion from the left side. Similarly, OH, H plus ions and OH minus ion from the right side. Now see, this have a Cl minus, right? Cl minus will be there. This Cl minus are, this is one more thing we remember here. So we have this electrode is which electrode it is, it carrying a positive charge. Okay, this carrying a what, sir? This carrying a negative charge. Remember, this is positive charge, this is negative charge. Okay, this positive charge will be there, no? It will attract the negative ion, which ions will move towards, and this is what is name of this electrode, sir? This is anode. This is what, sir? This is what, sir? This is cathode. Right, understand here. Now this Cl minus ions are going to attract by the positive electrode, and they are going to liberate as a chlorine gas. You can see chlorine gas is liberated here. Clear, no? Now chlorine completed. Okay, to discuss about the chlorine. Okay, chlorine, let me discuss about fluorine, right? Now better I'll write a reaction of fluorine. Where they are going to liberate, sir? They are going to liberate at, remember, they are going to, chloride ions are going to liberate at where, sir? At the anode. So let me write the reaction at anode. At anode. What happens, sir? At anode means a positive electrode it is. So at anode near two chloride minus ions will go there, and they have, see, Cl minus 1 means they have one extra electron. How many chlorines are there? Two are there. That's why two chlorines will combine, and they'll form a Cl2 by losing their two electron. So loss of electron, we can say it is a loss of electron. It is called oxidation. So remember, they can ask the question, in chloralkali process, chlorine will undergo what kind of process near the anode? What should be the answer? It should be the answer that it is oxidation. Now chlorine gas story is completed. Now come to the one more gases. Okay, which gases are we discussed here? One more gas is going to form here. Which gas it is? It is now chlorine gas is completed. You can see here chlorine gas is liberating here, and they given here chlorine gas is used in the water treatment, swimming pools, polyvinyl chloride, disinfectants, and chlorofluorocarbons, and pesticides. Just remember, they can ask the question. The gas X is liberated near the anode, which is used in the manufacturing of chlorofluorocarbon. Gas is what, sir? This gas. Find the X, they will ask. Okay, now come to the sodium plus ion. The sodium plus ion carrying a positive charge, and they will move towards which electrode? They'll move towards which electrodes are negative electrode. Negative electrode, which is negative electrode? Yes, sir, cathode. Okay, now sodium came here, and the speciality of this one will be it will send the sodium this side. Why? Sodium ions are smaller as compared to the sodium atom. So this will allow the sodium ions, because this is small, it is a small ion, so that it can escape through this pores of this membrane, right? Now sodium ion came near where, sir? Near the cathode, right? Now come to the from this right side. Now see, right side we have a hydrogen. We have a hydrogen ions. Okay, now see, try to understand here what happened here. See, now see, this chlorine ion came here. What happens, sir? This chlorine ions lost their electrons. How many electrons are? Two electrons. This electron, where they entered, sir? They entered here near the anode, and they are moving towards in this direction. This direction, these electrons will come here. These will be enter this electrode. That is gained by the water. Gained by the water. What happens now? This water will be there, no? This water, let you write here. Okay, let's remember the diagram. So now see, this chlorine will be, chlorine ion was there. Now at I'll write at the cathode. At cathode, what happens, sir? This water was there. This water will be split into H plus ions and OH minus ion. Okay, this water, this two H plus ion will gain that two electron. Which electron came from this chloride iron chloride gas is going to produce, chlorine gas is produced near the anode, right? And they are given the electron, and those electrons are through that circuit enter, and then they came near the cathode. That is gained by the H plus ion. So gaining of electron, what I can say, gaining of electron is what we can say, gain of electron. This is called what, sir? This is called a reduction. They can ask the question, which gas will undergo the reduction at the cathode. So cathode means, remember, negative potential. Clear? Now this is completed. Now come to the remaining part. Remaining part of the structure. You see now, see OH. Why can't OH in this direction? So because this membrane is not allows OH minus ion to this direction. Similarly, Cl minus in this direction because they are bigger. They want to go here. They want to go. They can ask the question, sir. Here we have H plus ion, sir. Why it can't attract Cl minus ion? Because of this membrane, because of this membrane. Okay, right, I understand. Here we said different ions are there. Why they can't combine? Because of this membrane. The speciality of this membrane. Now, similarly, NH plus Na plus ions will come near the cathode, and they will interact with OH minus ions, and they are going to form a NaOH at the downside of the near the cathode. Not, we can't say downside of the, it's near the cathode. Okay. Now see, you try to understand here. Here you try to understand here what I'm saying here. There is a chance of, mixing of these ions. No? Why these ions will not mix here? We have H plus ion, Cl minus ion. Why they can mix? No, because that membrane will not allow. So this will not allow. Cl will not move. That's why Cl will move. U turn. It will move towards the which are near the anode. Okay. This is about molecular process. Let me discuss final reaction. Okay. Final reaction. Try to understand. This is about reaction at anode. This is about reaction at cathode. Remaining is there. Remaining part will be there. No, remaining part now. So final I'll write here NaCl, NaCl plus H2O gives rise to Na plus ion and OH minus ion. Similarly, we have a H plus ions and Cl minus ion. Okay. Now this will give us what, sir? This will be liberated as S2. This will be liberated as what, sir? Cl2, and this will be forms what, sir? NaOH. So let me discuss. Let me write final equation. Final equation I'll write as NaCl, aqueous NaCl plus H2O gives rise to Cl2 plus NaOH plus H2. Okay, that's what is called chlor. Chlor means chlorine. Alkali means NaOH. That's what is labeled as chloralkali process. So chloralkali process, which are the important products are, one is chlorine, second one is alkali. Which alkali? NaOH. One more we have a gas called hydrogen gas. Just to remember. Okay. So now let me discuss about the uses they given here. So where this will be used. Okay. Now we can see here. Yes, they given here uses. Let we erase these all things. Okay. They given uses here. You see they given here. Chlorine gas is used in the water treatment, swimming pools, polyvinyl chloride, manufacturing of polyvinyl chloride, disinfectants, chlorofluorocarbon, and pesticides. Okay, so fuels, hydrogen gas, very well. On burning hydrogen gas is produced water. Where it is used, sir? It is used in the jet aeroplanes. Okay, similarly, margarine, very well, preparation of vanaspati vegetable oil into ghee. So we have CH2 double bond CH2 plus H2 gives rise to CH3 single bond CH3. Okay, in the presence of nickel or palladium as a catalyst. That is margarine. Vanaspati ghee is also called margarine. Preparation of ammonia. So you know very well ammonia reaction is what, sir? N2 plus S2 gives rise to NH3. Okay. ammonia they'll use 2NH3, 3N. Okay, this is preparation of ammonia, they will use hydrogen. Similarly, now you can see that for fertilizers, degreasing agent, remove the grease, soap and detergents, paper making industry, artificial fibers. In this area, these all things are used. Okay, so okay, thank you for watching. Thank you for watching. Please subscribe, share, and click the bell icon if you like the video. Thank you. Thank you all.